Yeah, so basically, before to my person, I'm Ralf Neeb. I'm working in Munich, and we are working in the whole high availability, high security area, and for many years now. Let's say even for more than a decade. And typically, we started in that area with FreeBSD and OpenBSD, and we were always looking for other operating systems to use, because from my point of view, FreeBSD and also monolithic kernels do not a good job in terms of security and reliability. And also I was working a lot of in the distributed systems and Crawler environment, also things like that, and so I'm more common to think in components and less in kind of monolithic spaces and things like that. So I was aware of Linux. I think, I don't know, about 15 years or something like that. I was the first operating system from ND I knew was Amoeba, where I had contact with. And after that, I also found the whole Minix stuff and was quite interested, as I saw with the announcement of Minix 3, that it's more targeting towards operational approach, and to make it usable and to make it more rock solid, to be broader in an area to apply. So, how to install Minix? No, I do not want to explain it to you in detail, just to tell you the more or less official approach in the wiki is taking an ISO and using Atabi on SATA optical drive and make sure that it runs. It's okay, but especially for us, we are working mostly on embedded devices. You will not have an optical drive at all, and so it's just hard to make it run. So what we did was we are using the image being generated by the x86 HD image SH, and the image was initially meant for QEMU only, and so it was just not bootable. You can use it with QEMU, but then you have to use the kernel, also things like that, outside the image, which makes it hard to boot at all. So our effort to make it run was more or less a double effort, and was not committed by us because another one was quicker. But at the end, it's okay, because now the image is definitely bootable, because now the image contains a master boot record, contains a kernel, also things like that, to really make it sure it runs. So you can just use that image, write it to a USB stick or whatever, and to make it at least possible to start the RAM disk. That's the very first part for us, is we try to make it run on other systems. Just have a look on a custom RAM disk and make sure, hey, okay, which drivers are already there, which are working, which are not, what we have to do. So we tried it with our first device. It's a little bit older, but it has at least something like a PS2 adapter and things like that, because I think more or less everyone knows it. We still have no USB support on Minix, and so we have to make sure that we have at least a kind of keyboard to make it. And we put it with an LP 172, and it's just an Intel Atom processor, and it has an Intel network interface, which is definitely working on Minix 2. So, how to do it? Just create your image, write it to your SATA hard disk or whatever you have, You can even write it to an SSD too. I do not know how much sense it makes to use an SSD because I don't have an idea how long does it last without trim. And I do not know the internals of Minix file system at all to have a kind of idea how much, how many reads and writes are really done. So we just booted it. We found out, hey, okay, the serial just works, everything's fine. We could do it. We could also do the netconf. Could configure it to use DHCP, and after that everything was there. The only change we had to make for the master, and we also committed it because quite small, was the missing device ID. So now that board is definitely completely supported, so it means you can really use it for everything you want. It's just there. The second board we tried was an Alex. Maybe you know it in a different context. Alex boards were heavily used before for firewall distributions like Monoball, created by Manuel Kasper in Switzerland, and also heavily used by pfSense, another BSD-based firewall. It's also quite old. I do not know, I think it was introduced 8 years, 10 years ago, something like that. But it has a very interesting feature set. Means you have just your AMD GO LX800 chipset with a 500 megahertz processor, and you already have 3 network interfaces there, where you can really use it quite good for firewall appliances, all things like that. And the other thing, it was 8 years ago very less power consuming. Now it wastes a lot of power compared to our, I would say, more recent inter-atom platforms. That one was a little bit harder to make it work compared to the LP172. The good thing, it's a CF card, and the CF card is connected via IDE controller, and so it's just like an IDE controller, and it works out of the box with the ATA driver Minix already has. So we booted it, serial works, everything's fine, okay, but then PCI panics, PC keyboard panics, and we had to find out that ATA won't work with DMA on that specific board. So the PCI fix was not so hard. The previous PCI implementation expected that the PCI host controller is always on bus 0, device 0, function 0. But yeah, it's a kind of quasi-standard used by Intel, but it's never written down in the specs that it always has to be 0, 0, 0. And so we had to find another way to enumerate the existing devices on the bus. And another thing was the PC keyboard controller. The PC keyboard controller could not imagine before that you will run Minix on a system without a PC keyboard controller at all. So, okay, it was also not so hard to convince him that there are systems without a PC keyboard controller out there, and he just made it work, and also did the whole stuff in the RC script in the RAM disk to make sure that it's running smoothly. And we also added an Alex option to the boot entries in the bootloader, and so you can just use the existing master of Minix, check it out, build it, use the image, write it to the compact flash card, and it will completely run on every ALIX box completely. The only thing which will not work right now is network, because we do not have a wire Rhine driver already there in Minix. But yeah, if someone wants to do it, we can talk about to donate a board to the guy who tries it. So it's not a matter of that. It's more like trying out how to make it. The successor of the ALIX board was the ARPU. ARPU was the second one. Is a most recent platform developed by Pascal Donnier in Switzerland. It's the owner of PC Engines, and the new one uses an AMD G series with 1 GHz and dual core, and you still have a memory card, but now it's not longer a CF card, it's an SD card, and the SD card is connected to the whole bus via USB. So that makes it quite hard to boot at the moment with it, but it still has mini PCI Express and mSATA slots, and so you can use your mSATA SSD, or you can also use on a SATA port a regular hard disk. That's still the same for ARPU. It just works so far. Means you have a serial, you can install it, you can use the image which is in the master already. But same here, the real technique is not recognized at the moment. I expect here chances to make it run higher than the via Rhine driver, because the via Rhine driver is just not there at all. But the Realtek 8111 driver, or the driver for that is the same as the 8169, and the 8169 driver is already there in Minix, so I expect it's more or less a slightly adaptation to make it run. That could be a good, cheap and affordable platform to test Minix, just in terms of writing a new network stack to find out how routing should work, how, as we learned before, link aggregation could work, and other things like that, because now you really have 3 network interfaces already on board. And I do not know how much does it cost at the moment, but I think the last time I looked at it was 110 or 120 euros, and so it's not so expensive. Here is a question I had before, was using an SSD without trim. Maybe someone will look into it and may answer it in a couple of months. So then we came to our big adventure. The Mino board was, I would say, not very willing to help us. The Mino board, maybe you know it, the Mino board is a kind of the Intel development kit for embedded computing. So it's a kind of blueprint, proof of concept board. It comes with an Intel Atom E3825, which means 2 cores and the 5th stepping. And it has a complete bait rail support, which is quite important for us, because we are really targeting bait rail chipsets at the moment, and also we are moving slightly at the moment towards Skylake, and working together with some industry partners to make it work. And MinoBoard Max has an SDIO, so you can also use an SD card. It's not connected to USB, but hey, will not work at all, because it has it's connected to an SDHC. So it means you also have to implement the whole ST host controller things too, where you can use it for an SD card and for eMMC cards, which are also part of the bait rail chipset. It also has a Realtek 8111. It's in GS, not an E. So I would expect refactoring the Realtek 8169 driver would make sense to address both cards at all. And it has already an XHCI, where you can use it for USB 3 too. Then we have two very, very interesting things. It has a high speed serial, which not longer built in via an UART. It's built in via a PCI device. So right now, Minix cannot deal with it because it's always written to an address for 3F8 and also things like that to make sure that it's running. And so we also have another problem. It's completely delivered with an UEFI 64-bit BIOS. It's with a Tiano project, and so you have to do a lot of things to make it work in the first time, but the good thing is at least it works on Minoboard 2 with a serial. Wow. So first thing, still the same, use your image, write it to a startup disk, and then the first thing you have to do on Minoboard is find out where you get the power for your SATA port at all. Because it's only the SATA data port and not the SATA power port. So you have two holes, so no pins are there. And so yeah, so get into your favorite electronic market, find a multimeter and all the things like that, because all the things you read in the internet are more or less completely useless for that, because they tell, hey, okay, we change the pins in revision A, B, C, D, E, F, and it's more or less always doubling. We say, hey, okay, no, I will have my multimeter now. Okay, solved it. SATA disk started, everything was fine, so I connected via the serial TTL adapter directly to the debug UART, booted it, so the bootloader, nothing else. So, okay, why you are not longer talking to me? First thing, maybe for the sequence I forgot before, I had to downgrade from 64-bit UEFI to 32-bit UEFI, because otherwise we won't boot at all. The good thing is you can even boot on a UEFI BIOS without having GBT on it, so you can also use it with a regular partition-based approach, but you have to take care that you have your own UEFI partitions there. Works completely with group, so we made it with group because NetBSD bootloaders were slightly fixed for Minix. And so yeah, we saw it and we just asked ourselves, hey, why we are not getting more information? We are using core boot, flash core boot on Minoboard instead of the UEFI stuff. Because then we had at least a BIOS, because UEFI does not have a BIOS any longer. And we found out in the Minix kernel that there are a lot of VGA BIOS calls are inside the kernel to write text to the console. Sure, if you start via UEFI, no BIOS there, no safeguarding for using the VGA BIOS calls, so just makes boot. And nice interpretation of the UEFI of the Tiano interface implementation. Tiano UEFI comes without a CSM. Typically, other BIOSes or commercial BIOSes already also include a CSM, where you have your compatibility software module, which contains more or less a BIOS inside UEFI, and so you can also use it with a legacy operating system. Tiano is not able to add a CSM because there's no space left to add it. Just a small side note, the whole SPI memory on Tiano is 8 megabytes. and they just do not make it to add, I do not know, 200 kilobytes or something like that, because because you have to include also quite a huge binary support package from Intel for your base array support to make it running at all for the whole memory initialization and things like that, because even if Intel tells you it's open source, it's not so really open source, because yeah, it's just a big blob for your MSP. So after that, all the things were fine. We just managed it to boot, and we saw it. Then we had a first bug in core boot. Core boot did not initialize the debug UART. Means MinoBoard has 3 UARTs. 2 high-speed extensions, which are connected via the GPIO pins, and 1 which is connected via the debug UART. And yeah, so it was quite interesting to find out, hey, okay, so they're trying to write to another thing, and core boot did not initialize the debug UART before, so you could not use it. Okay, that fixed that, committed it, everything's done. The core boot guys quite cooperative and quite willing to support things like that. And so we already made it to boot. Then same thing, seeing the serial was there. Okay, now we saw a little bit more. Still the bootloader, but at least we could see some other stuff on the monitor, because VGA or VGA was now there. And so we found out, okay, looking there, why we are not getting data via serial, or things like that. And yeah, went crazy to find it. And after that, a couple of weeks later, as we put it in the corner and thought, no, we will not touch it again. A couple of weeks later, we thought, hey, okay, sure, the debug UART is only 3 pins. Means you only have an RX, TX, and a ground. So they do not have RTS and CTS. But the console in Minix was built using RTS and CTS. Okay, so it was quite easy after knowing that. We just commented it out, made it behind an if-def, and so that you can do it at least for compile time. Maybe we manage it in the next days to also make it configurable via a boot option and committing it then to the master. And that was more or less is a breakthrough to make it completely working on MinoBoard 2. Now you can also use an image as it is in the master, put it on your SATA disk, and everything's fine. You can really boot it and can start from that on bare metal, because what I've learned in the whole operating system development in the last, I don't know, many years was there's nothing like bare metal, right? You can use a lot of emulators, and a lot of emulators will work for certain things, but at the end it has to work on bare metal and nothing else. And so maybe it's an interesting platform for the Minix community also to start from that point developing the other features. Because now you really have more or less, I would say, a very recent platform with base array support, where you can start with integrating all the other stuff. So then we also have another one, that's more or less a powerhouse from our embedded platforms we are using at the moment. It's the IP897, uses an Intel Atom E3845, means it has 4 cores. Okay, it's a kind of pointless to talk about many cores in Minix, but hey, okay, there are 4 cores. And it's still the base rate, but the more interesting thing on that board is it already has 2 NICs on board, and personally I prefer Intel NICs because they're definitely less compute intensive for workloads than Realtek NICs. And that's the same here. We are also working on it to support the the Intel network drivers to make it run. And that one came also with up to, I do not know exactly, I think it came with up to 16 gigabytes memory. Okay, also not so interesting fact for Minix as we are still bound to 4 gigabytes, but at least it will be a good platform to start for all the things like port address extensions or even 64-bit. So here we have one major drawback. We do not have a keyboard because it's USB only. There's no PS2 any longer. At least the BIOS is a commercial BIOS. It's not a piano core, so it means you have all still the compatibility mode for the BIOS. So that means that's the current status for us. It's just for the slides to see it later, but serial low speed is a thing. I would say every board we mentioned here can serve as a good starting point to work with Minix at all, because now you really have a possibility to run on bare metal via serial console, and you are not longer forced to use QEMU, VirtualBox, Parallels, whatever, because they all just behave differently. So, what was our resume for using Minix on that? No major changes are needed. The only things we need to change is make sure that the kernel is getting rid of VGA BIOS calls at all writing to the text console. It's not a big task. The other one is streamlining boot process would help tremendously. Now we are not longer having BIOSes only. We really have UEFI. We also have other appliances like Intel Edison board with IoT things. You also have U-boot installations and things like that. The next target we are working on is to make sure that Minix runs on the Intel Compute Stick 2. Maybe you know it. It's a small stick, more or less as big as the Google Chromecast, where you can put in directly via HDMI into your monitor and has a complete computer on board with an Intel Atom Z series. And so here. Last slide for us. 12U 32-bit CPUs still available for the Intel world, so definitely makes sense to target other architectures. And we also address right now a lot of buses where we do development for a new PCI Express, where we also do development for the XHCI and EHCI. We already have EHCI completely running for the control transfers. We also developed the whole USB stack, USB 2 stack for that. And we are also working at the moment to finalizing the XHCI with a USB 3 stack to make it ready to use. And also the STHC for the secure digital, which would allow us to use eMMC and the SD cards quite well. So means at least having STHC running would allow us to boot directly for the Mino board. Good. So, thanks for your... Time for one question. Sorry for that.
Hello, I've been working on the ARM port for Minix, and many of the problems I'll see is probably that we had. I'm sure that the ARM port does not do any BIOS call. Have you had a look at how the code was restructured? Could we follow the same approach for other platforms, or is Intel work really left as is?
No, sure, we really looked at it before, sure. And for us it was more like having a kind of monolithic approach for the services and for the user land too. Because what we saw, for example, in the ARM port was ARM already has a USB stack. But the USB stack is more or less just one big process. So that's not what we would like to understand from a microkernel architecture at all. for us, it's more important to really have something like an own process for your HCT, an own process for your USB-D, and an own process for all the drivers on top. And that was not there already, and so that means at the end, for us, it would take more time or more effort to refactor both of it. And so just did it for the Intel stuff, and maybe we can port it to ARM too, but not our primary focus.
Thank you.
All right, thank you.